Welcome to your video lecture that is all about river health, or how we determine scientifically the health of a river. So copy down this one vocab word. I got a little excited yesterday, gave you one more word than you were assigned. So you only have one word today, and that is intrusion or saltwater intrusion. Now I apologize, on your paper it might just say intrusion, but I meant to put saltwater intrusion, so please write saltwater right there on your vocab words. All right, now this is where we have salt water, or water from the ocean, intrude or go into the freshwater aquifers. Now, this is not only a bad thing because it's salt water instead of fresh water, but if you and I try to go drink these, it is just not going to work. It's actually going to make us sick. So it's a bad thing. It's a thing that's happening along the coast because of how heavily we are pulling from aquifers. So as we pull from the freshwater aquifers, fixing some things in here. As we pull from the freshwater aquifers, that pressure that's created along the coast, if we pull too far on the aquifers, will actually bring some of that seawater into the system, making it salty. Now, this is happening along the coast, but it's specifically happening along areas that are very heavily populated along the coast. So, not a good thing that's happening, but it is happening, just so you know. It's one way that water can be contaminated. All right. Now, I've got a picture for you of your local lake, Jones Lake. I would like you to predict for me the water quality of this lake. Our goal today is to be able to learn about the scientific kind of test that we do that's going to tell us whether or not this water truly is of good quality. Okay? So that's your bell ringer. Predict the quality of this water. Now, explain why you chose this rating. So whether good, bad, in between, you don't know. Explain why you chose that rating. That's your bell ringer today. Now, if you will, we're going to have a little bit of a story time before we jump into our notes today. So imagine that this is your view. This is what you're seeing right then and there. Imagine you just slowly walk down the long dock to sit and stare out into the depths of the brown water. You look out at the sweet bay magnolia trees typical of a wetland habitat. Had you made this journey in the spring, you could see the large white blooms dotting the evergreen forest and smell their sweet scent. Your gaze goes back to the brown water and you search for life under the water. You start to squint and even move from your bench to the pier to get a closer look. You hear what sounds like a high-pitched yoo-hoo from the lone Atlantic white cedar among the bay and pine trees. It's the call of a chickadee. Back to the pond your attention goes, trying to glimpse the underwater world. You stare there at the ripples of water as they move across the lake. All your efforts are in vain though, not a fish in sight, and you are left with the thought of, I wonder why all the fish are gone. That's our goal today, to figure out maybe why there are less fish in this lake. All right, with that, let's get started. So we are learning today about indicators of water quality. Now you could just look at the water and say, that doesn't look very good. And that's kind of what we did yesterday with our bell ringer. But we're actually going to learn some scientific tests that are common of lakes and rivers and freshwater systems to determine the health of those systems. So the very first one is called turbidity. Now this is the measure of the degree to which water loses its transparency due to the presence of suspended sediment. The Mississippi River is an example of a high turbidity body of water. So this would be asking you basically, can you see the bottom of the lake? Now, the more water you get, no matter how clear it is, the more likely you are to have sediments in it. More water, more sediments. So it is likely that as you walk deeper into a body of water, if you this should be something you could have seen in your everyday life as you walk deeper into the body of water. It's less likely that you'll be able to see down into the water. But the turbidity is what is causing this. So it's due to the presence of suspended sediments. Now, we talked yesterday, sediments can actually be a pollutant in a river. We talked about how when we have too many of them, like this picture right here, which I assume is the Mississippi River, I believe, if I remember right, that you can't see the bottom, and if you can't see the bottom, the light is also having a hard time getting to the bottom of the water too. That's a bad thing, one, because it's not going to warm the water as much, but more likely it is actually going to prevent our producers like algae and seagrass and some phytoplankton from producing because they need the light. So, and if you don't have producers in a system, you're not going to have all the herbivores or carnivores or omnivores that are later down that food chain or food line. So it's a big deal that a lake or river is very turbid. Now, if you remember right, thinking back to our lecture on rivers, the faster a river is going, the more sediments it can carry. So a slow-moving river is more likely to have less sediments than a quickly moving river. Our next measurement that we will typically take, and you should have seen some of these. She didn't test turbidity, but when we watched the water quality testing video on Wednesday, she tested a lot of these. Here's some samples for you. So you would take a water sample, and you would pretty much just compare it to these right here, or something like this. So obviously 250 is way worse than like 50, but still 10 is better. So the smaller your turbidity number, the less turbid the water is. Causes of turbidity: sediments from erosion, we talked about that. Resuspended sediments from the bottom, so is the river eroding away the edges of its side? Is it picking up sediments that were settled on the bottom? Waste discharge, so as sources come in through the river, they can bring with them sediments. Algae growth can cause some turbidity, and urban runoff as well, with the sediments running off from urban areas, can cause the water of a river or lake to become more turbid or less see-through. Next is pH. pH, I think we talked about it a little bit when we talked about ocean acidification, but pH is the acidity of the water. So 0 to 7 is acidic, 7 to 14 is basic. Surface water, or surface fresh water, is usually 6.5 to 8. It's relatively neutral, meaning it's not really acidic and it's not really basic. Now, we do see a little bit of a difference here between swamps, like our wetlands, and our salt water, like what we're seeing in the ocean. Our ocean water is typically basic, and our swamps are usually acidic, but we did learn in the previous lesson with ocean acidification that CO2 combining with the water causes carbonic acid, which makes this just a little less basic. Now, changing pH in a stream can be an indicator of increasing pollution. Something is changing this pH. A little bit of a variation in between the pH of something is normal. It's normal to have kind of a up and down little thing, but anything that, like if I got a river reading that was like 3 for a lake or river, I would say something is definitely going wrong. And if I got something crazy like 14, that would be so basic that it would actually cause damage to whatever was in there. If you went swimming in there, it would burn you, okay? It would not be very good at all. It would hurt. My hair looks like this because of Nerd Day. I didn't realize how beautiful I was looking today. But anyway, so that's pH. Now, here's some causes or changes, reasons why a pH would change. So natural conditions, I told you they naturally change just a little bit. If you're dumping waste into a river or a water system, that could also change the pH. And farm runoff can also cause a change in pH of your water system. One of the problems with this change in pH is that most aquatic life cannot withstand water outside the usual pH range, thus resulting in death, like the fish right there that man has caught. So organisms, specifically aquatic ones, are very susceptible to changes in pH. It makes them die, pretty much. It kills them. So changing this pH like that is a big deal. Moving on to dissolved oxygen, that's the amount of water or oxygen in the water. Changes in the DO, which is how we shorten it, occur due to rapidly moving water. So if I have quickly moving water like you saw in the video on Wednesday, we would expect an increase in dissolved oxygen because it's bringing in more water molecules are coming in contact with the air, dissolving that. Increased temperatures will actually decrease the amount of dissolved oxygen. And then discharge from sewer pipes will cause a decrease in our dissolved oxygen levels because there's bacteria in those sewer pipes and those use up the oxygen in the system. If there's no oxygen in the system, the plants and the wildlife, the organisms like your fish, they end up dying. Okay. Dissolved oxygen. You want, I can't remember what she said was healthy for a dissolved oxygen level. I can't remember. I'll see if I can look it up. So, like I said, when the dissolved oxygen drops too low, fish dies. When DO is too high, water tastes better, but it can actually damage water pipes. So we need that sweet middle ground of the system. That is what is best for us and for our system. Let's see what you said was normal for dissolved oxygen. In your video, the Chesapeake Bay, one of the little streams there, they found a dissolved oxygen reading of 5.7, and that is healthy. So I would assume stuff around 5 and 6 in our dissolved oxygen concentration is healthy for a system. Good. Next, our next thing that we usually test when we are checking the health of our river is the temperature. So how hot or cold? And extreme high or low temperatures are only tolerated by hardy fish. So just like fish and aquatic organisms, they just really are really sensitive. So pH changes mess with them, temperature changes mess with them. So if they're not a hardy fish, meaning that they can withstand high or low, they're gonna die. So some reasons why we could have this change in temperature occur due to the source of water. So where's the water coming from? If we have an extreme drought where the water levels for some reason the water levels were to drop, that's going to cause a increase in temperature of water because more solar energy is being absorbed by the less water molecules. Shade from shorelines can actually cause the water to be colder. And then the biggest one, though, that we learned about that was man-made yesterday is that factory thermal pollution can happen by dumping heated water into lakes and rivers, decreasing species in the body of water. And we talked about a way to, or we will in a second, the more biodiverse an ecosystem is, the healthier it is. So if we're decreasing the number of species in a body of water, then we're decreasing the health as well. In my own life, I saw this. I used to try to keep a betta fish in college. My roommate gave him to me for my birthday. His name was Albus, and I'm not a good fish mother. But I tried to change his water, and it was too cold, and I actually gave him a seizure. He made it, but I realized I wasn't meant for him. Okay, nitrates is the next thing that we typically test, and we're going to move through these pretty quickly. But this comes from fertilizer, and we're going to talk a lot about this when we talk about eutrophication, which will be another lecture. But fertilizer, which is an ingredient used in agriculture, so algae and other plants use the nitrates just like our crops do. And if the algae have a limited source of nitrates, the algae bloom so much, which reduces the dissolved oxygen content in the water, leading to less oxygen and fish and insect death, which is not good. Ecosystems die because of this. And then this one right here has an excess of nitrogen. And lastly and quickly, bioindicators. So there are special populations that will actually indicate if an ecosystem or river is healthy or not. Some examples are amphibians. Got a lot of frogs, you got a healthy ecosystem. All right, have a good day.